Hello everyone, I hope you are doing well. So in today's video, we are going to go through the 2024 VCE Specialist Maths exam 2 for the multiple choice section. I hope you guys are enjoying your day. And if you guys are interested in private tutoring for subjects like specialist maths, maths methods, physics or chemistry, you can always email me through this email. So let's smash through this video. So, question 1. So before, just going through this paper, I'm going to try to go as deep as I can, explaining how I approach every question, and hopefully this helps you out. Let's smash through the first question. Consider this statement. For any integers m and n, if m plus n is greater or equal to 9, then m is greater or equal to 5, or n is greater or equal to 5. The contrapositive of this statement is what? So when I ever see this question, this is actually a kind of a typical question that has come up in many of the papers, like, the practice papers that you do, like Hefferman papers, Insight papers. A lot of these papers, they've started to put these types of questions. And one of the ways that I approach these questions is to write them as a prepositional statement. What do I mean by prepositional statement? It's basically like taking these words and basically making them like formulas, basically, like numerical values. Let me explain. This is how I kind of think about it. So for example, let me just put this highlighter. So for example, it says, if m plus n is greater or equal to 9, let's call this P. Let's call this P. Let's call that P. Then it's an implication, yeah? This then is actually an implication, so let me highlight that. This is an implication, and an implication looks like this. It's an arrow. It implies. Then this whole statement over here. And we can also highlight this. So let's call this Q. You see that? So m plus n is greater or equal to 9. Then, so it implies m is greater or equal to 5 or n is greater or equal to 5. So let's write that down. Basically, this statement gives us this. P implies Q. Great. But what the contrapositive of this, implication is, by the way, for contrapositive, all you need to do is you need to just rearrange this. So bring Q, bring Q this way, and you take the negation of both. So negation of Q and then negation of P. Can you see how I've just basically swapped these around and I negated them, basically the opposite of them. And basically that's it. Now, there is a problem. If you don't look at Q right here, Q has multiple parts. Look, it has the word or, yeah? There's actually multiple. There's 2 parts to Q. So let's actually break down Q much more simpler. So we can actually write Q into 2 parts, because, let's consider this part here as A. So let's consider this part as A. And let's consider this part as B. And so basically what we're saying is, by the way, or is union. Like probability when we say or. So, for example, this is A. Union, when we write union, we write it like this. We don't write it in a U. That's U in terms of method. But for proofs, we use that V. It's like a union. B. This is what basically Q is. And what we want is the negation of it. So to find the negation, we have to use De Morgan's law, where we basically negate this and negate this. But what we have to do is flip this sign. So we negate A. Then we flip the sign and negate B. This is one of the De Morgan's law. And now this is an or. Now it becomes an and, like an intersection from your methods or probability, yeah? So look, we can actually write this in terms of that. So, we can, how negation of Q is just equal to that. So we can write that down here. So we can replace this here. So to this, negation of A, intersection, negation of B, implies negation of P. Beautiful. You see how we've basically simplified this whole thing into these little symbols, and it makes it so much easier to understand. And now we can actually write this whole thing. So first of all, this is our contrapositive, and now we can write it. So what's the negation of A? So you know how A is m is greater or equal to 5? What's the opposite of it? What's the, if m is greater or equal to 5, then m is less than 5. The opposite, so negating it. You remember this here is intersection, so or basically means and. And this here is the negation of B. So you know how n is greater or equal to 5? It's going to be n is less than 5. And remember, this is implication, which means then. So writing it in terms means then. And the negation of P, so if m plus n is greater or equal to 9, it's going to be m plus n is less than 9. And this is our statement. This is our contrapositive statement. So let's compare that to all our answers. First of all, 100% it's not D and it's not B because you have the greater or equal. They're supposed to not be greater or equal and stuff. And the difference between A and C, it's C because C has and. Look, can you see how it's M is less than 5? We have that. And N is less than 5. Then M plus N is less than 9. You see how beautiful just doing that can simplify this whole thing? And that's what you want to do, especially in a paper. I love doing this way. It just makes it simple. Hope that makes sense. Question 2. Consider the function f with this rule. Okay, f of x is this, where x is an element of reals, and we have 2. Okay, which of following statement is correct? Now, one other thing about this is just graph it using your CAS. Let's have a graph of it. Let's go to our graph and graph it. So let me open up add graph. And so what I'm going to do is open, so of course it's let me open a hybrid function and let's write that down. So x squared plus 3x minus 10, x minus 2, and basically x is all reals, except 2. So we can say, x is less than 2 and x is greater than, I don't know if this should work like that. Yep. And then, 7 and x equals 2. No, it's not really showing, huh? So maybe, let me just try to break it up. I think because it's too much input, what I'm thinking is, because I think this domain is just really ugly. What about if I just let this part here? Yeah, then it works, yeah? Then what I'm going to do is, for the other part of it, I'm just going to copy this here, write it here, and write x is also greater than 2 to get the other part. And so this is what it is. Yeah, it's a straight line. And it makes sense. Let's come back to our iPad and let's explain why it's a straight line. It's very easy. So going back to this actually can factorize. You can factorize the top part. So let's factorize it. 2 things that multiply to give us x is xx. And 2 things that multiply to give us 10 is 5, 2. And you put a minus here, using and that basically you can factorize that expression to x plus 5 and x minus 2. So this here can be factorized to that. And don't forget, it's divided by x minus 2. Aha, that's why it's a straight line. Look at this. This here, you can see that these cross out. Now, when you're crossing out, basically what this is going to create, it's going to create a hole, an actual hole within the equation. So, for example, so when you cross these out, you'll be left out with the equation x plus 5, which is just a straight line. So if I was graphing this whole equation, let's actually graph it to really visualize what's happening here. So like this and like this. So basically it's a straight line, x plus 5 basically goes like this. It looks like this. Like this, where this is this coordinate here is 0, 5. And basically what's going to happen is at x equals 2, it's going to be a hole. Because you're actually you can see that the domain is restricted to x is all element, all reals except 2, and it makes sense. You've crossed these out, so it's actually a hole at x equals 2. So what that means is at x equals 2 here, there's going to be a hole. So somewhere around here, let's say, and we can draw a little hole here like that. This is like a hole. And yeah, basically that's what this function is. And that's why you can graph it, and yeah. Now the next part is, to draw this, it's basically drawing the y equals 7 line at x equals 2. Now I just want to double check. What's the y value for this hole? So if I sub in 2 here, it'll give us 7. Aha, basically what this does is that this here fills in that hole. Look, you draw y equals 7 line at x equals 2 only. It fills in that hole. So basically, this other part here just fills in that hole. Now we filled in that hole, yeah? Now, that's basically it. This is what this whole function is. That's why when we graphed in our CAS, that's what it looked. It just looked like a straight line. So let's look at the question here. Which of the following statements is correct? The function f is continuous. Yes, it is continuous. Can you see that there's no discontinuity or any holes? If there was any holes, it's not continuous because, it's not very much continuous. As you can see, it's continuous at every part. There's no holes, there's no gaps, there's nothing. So you can put a tick on that. Next question. The graph of f of x has a vertical asymptote. Not true, actually. It doesn't have a vertical. It is again, when we graphed it, it didn't have it. This is how the graph looks like. There is no vertical asymptote. Because, of course, these cancel out, that x minus 2. So be careful with that. There's actually no vertical asymptote. The graph of f of x has a horizontal asymptote? Absolutely not. As you can see from this graph, it does, and we've also checked it with our CAS. The graph of f of x has a point of discontinuity. It had a point of discontinuity, but this function here, this little function actually filled in that hole. So it's not discontinuous, it's actually continuous. So it's 2a. Hope that makes sense. Beautiful. It's a really nice question. So yeah. Question 3. The graph of f of x, x minus h, this whole thing, where h is an element of order, so h can be anything, will have no turning points when. This is an easy question. With your CAS, this is so easy. When I see a question like this, it's the beautiful, like so beautiful, because you can just use a slider and really just, check out all these values, check out this value, check out this value, and check which one fits that condition where it has no turning points. And let's do that actually. Let's actually do that. So I'm going to control N this, and what I'm going to do is I'm going to do that. So first of all, I will, of course, graph this. So x minus h, x plus 1 times x minus 4. And I'm going to put a slider for h. Now, let's try the first one. The first, let me just move this up here, and this is ugly. Let me take this somewhere here. Okay, so the first one says that h is less than -1 and h is greater than 4. So, okay, so for example, -4, so negative 4's here. So wait, sorry, what am I saying? -1's here, yeah? You're saying h is less than -1. So at -1, you can see that there is turning points. Look, when h is less than -1 and not, by the way, not basically equal to, like, for example, so not equal to -1, but when h is less than -1, we have all turning points. But that's not what we want. So A is wrong. It's saying h is less than -1. Look, if we go and look less than -1, we have turning points. We want no turning points. So A is absolutely wrong. We can actually just take that off. Okay, now B is saying it's between -4 to 1. Let's check that out. So if I put -4 here and put 1 here, where, they're not inclusive, so, so -4 is not inclusive. So that's good. And as you can see, no, you can see that there's still turning points. That's also wrong. So B is also wrong. C, it's saying it's between -1 to 4. Let's check that out. So -1 to 4. And let's check that out. Okay, so we can see that there's actually no turning points here. Look, from -1, and look, 4 is inclusive. Look, there's still no turning point. Oh my God, this is fitting everything perfectly. So it looks like C is could be our answer. So I'm going to put a tick on that. And the next one is -4 to 1. -4 to 1. And again, rubbish, because here we have turning points. So it's actually C. That's how good it is. You can actually just do this in a CAS so quickly. Now, of course, if you wanted to do it by, algebra, you can do it. Is it worth it? Not really. It's a multiple choice. It's only 1 mark. So how would you also, let's just explain. How would you also do this in your CAS? Let's just talk about our critical thinking here. So what you need to do here, for example, is, okay, let's define this function. Let's do it by CAS. How would you do this? Now, this is really easy, just doing it by CAS. X plus 1 times x plus 2. So this is also important to know how to do it by CAS. Okay. There it is. And what you want to do, of course, is to find any stationary point or any turning point, you derive f of x. And of course, you let it equal to 0 and you solve for x. There it is. And these are your x values for your turning points. Now, what we want to do is if we don't want turning points. So we want to find a way we don't want these x values to exist. Now, this is the beauty of this. There's a square root within both of them. And this square root's the same. Look, h squared minus 3h minus 4, the same with this one, yeah? So think about it. How do we make these values not exist? What should we do is we know that a square root doesn't exist if the value inside is negative. So for example, we can just take this one over here, because they're the same, by the way. That doesn't matter. You can just take any, and you can solve this for less than 0. So negative, and you can solve answer, comma, h. And you can see h is between -1 to 4. Now, it is close to our answer but the difference between our answer, just looking at my one, it's that -1 and 4 are included, which is true. See, this is the problem about, I think just doing algebra, it's better just using a slider. You can actually check those values realistically. Sometimes, look, you can get this, but you need to double check them with the CAS, yeah? For example, if I just, take this and, as you can see, if I just graph them, look, if I just graph them, h here, you can see that this here, -1 to 4, -1 here and 4 here, from my answer. Look, -1 to 4, there's no turning point, but look, also, like, we're saying not including 4, but if I include 4, it's still no turning point. Also, -1 and 4 are inclusive, so be careful. Don't fall that mistake, yeah? Those are of course, inclusive, yeah? Like, that's what our multiple choice says. So it's actually this as your answer. So it's C. Perfect. Let's go to the next question. Question 4. Given us sine x is equal to a, where x is between 3 pi over 2 to 2 pi, then cos x over 2 is equal to what? Not gonna lie, if I'm in an exam, I'm not even thinking. I'm sure that we're gonna guess some values. Not guess values, but try to put values that work for all of these conditions and get the answer as quick as I can. Let me explain. So I'll show you how to first do it, how I would approach it using a CAS, of course. And then I will also show you how I would, for example, do it by hand, explaining it by, doing it by hand. So let's first look at this. Okay, it says, let's have a look at this. It says, given that sine x is equal to a, where they don't tell us what if a is positive or a is negative, x is between 3 pi over 2 to 2 pi. What does this mean? Let's think about this. So your x value, 3 pi over 2 to 2 pi is in this quadrant over here, which is quadrant 4, where only cosine is positive, yeah? Only cos is positive. Remember this area here? Only cos is positive. Now, we're trying to find cos x over 2. So what I'm going to, what am I actually doing is, I'm just doing it right now by hand, which I shouldn't do that. Forget about that. Let's actually just do it normally. How I would do it if I was, stressed, I'm in the exam, and I want to do it as quick as possible. What I'm going to do is do this. I'm going to put, first of all, an x value that is within this domain, as we are seeing. So I'm going to just pick a value that's between 3 pi over 2 to 2 pi. For example, 2 pi minus pi over 4, which is 7 pi over 4. So 7 pi over 4 is within this domain, yeah? Isn't that correct? Yes, it is. So I'm going to actually put that as an x value. Look, x is equal to 7 pi over 4. Look, I'm making sure that they all fit within every condition. So beautiful. It fits in with that condition. And so what's sine x equals a? So I'm going to actually just put what's sine, and our x value, of course, is 7 pi over 4. And that's going to give us our value of a. And that's also going to be my value of a. That's what I'm going to try to find. So let's go to our CAS. So basically, what is sine 7 pi over 4? 7 pi over 4. And that's negative root 2 over 2. Let's write that down. That's negative root 2 over 2. Done, yeah? So we've got these x value and a value, yeah? And what I'm trying to find in this case is cos x over 2, yeah? So just if you look at your formula sheet, we know for a fact that in your formula sheet, we have something called cos 2x is equal to, what am I even doing? I'm trying to fit... I'm tweaking because I'm trying to think of doing it by hand, but I'm not supposed to do it by hand. I'm trying to do the fast method. So, okay, we got x and a, yeah? What should we do then? Well, quite obvious. Why don't we just sub it into here? So we want to find cos. What's our x value? Our x value, of course, is 7 pi over 4. And don't forget, you need to divide it by 2, yeah? And that's going to be equal to one of these over here. And that's what we're going to do. We're going to put each one of these values. Let's do that. So I'm going to put this in my CAS. So, for example, cos, so 7 pi over 4 over 2. So, yeah, is equal to, I'm going to try the first one, yeah, which is negative, the square root 1 plus square root 1 minus a squared over root 2, where, of course, what is my... So for example, given that I know that my a value is negative root 2 over 2, this here. True, the first one works, so we could put a tick on the first one. So it could be a, you can say it could be a. Let's try b. So b is basically the whole thing, but this is changed. So now there's no negative here, there's a minus in here, and it's a squared plus 1. A squared minus 1. And that looks perfect. Enter, it's false, so it's not b. Look. Just a quick method. What about C? So C, again, everything's the same, but it's just this whole thing's changed. So again, there's a plus here, and that's going to be 1 minus x squared. 1 minus a squared. Which if you press enter, false, doesn't still work. So C is also wrong. And of course, D is, let's do D. So D is basically, there's a minus in front of it. You got 1 minus a squared, and don't forget minus 1 here. Enter, and it's still false. So all of them don't work. Only A works, so A should be your answer. That's how I would have done it, with basically just using my CAS, putting in values that work, that fit all those conditions. Now let's do it without, with actually how would you do it normally with, algebra. So let's do that also. and let's talk about that. So what I'm going to do here is do this. So I know that sine, x is equal to a. So I'm going to write that down. So I know that sine x equals a. I can write it as just a divided by 1 because this is very useful. First of all, I want to find cos x over 2. Now, I know for a fact from my formula sheet that cos 2x is equal to 2 cos squared x minus 1. Yeah? What I want here is I want x over 2. So what I'm going to do is divide these x's by 2. So I can write this whole thing as cos x equals 2 cosine squared x over 2 minus 1. Jackpot. As you can see, we are trying to solve this over here. So imagine I want to rearrange it. So plus 1 on both sides to get rid of this 1. So cos x plus 1. And then I'm going to divide it by 2. And then the positive negative square root of it. And so what I've done is I've actually rearranged this to get cos x over 2. Now be careful here. What is it? Is cos x over 2 positive or negative? The way we can double check is to look at our x value here, our domain. Yeah, our normal domain is of course 3 pi over 2 to 2 pi. Yeah, and so what happens when you do x over 2? So when you divide it by 2, the domain, of course you divide everything by 2. So it'll be 3 pi over 4. And where is that? Well, basically it's which domain? So it should be within so pi is here. It should be within here. It should be in quadrant 2, which is only sine is positive. But we're using cos. So then we have to take the negative, of course. Take the negative. Now, we're still making progress. Keep it up. So, of course, we have cos x. Now, we have sine x. Why is this so important to have that sine x? It's because if we draw a right angle triangle, yeah, we know that, of course, let's call this x, that this is our, our sine is opposite divided by hypotenuse. So, our opposite is a, and our hypotenuse is 1. So this is going to be, this part is 1 minus a squared. So what's cos? Of course, we know that cosine x is adjacent, which is, of course, 1 minus a squared over 1, which is just 1 minus a squared. Done. So we can actually sub that all in. So, okay, so it'll be 1 minus a squared. Don't forget that plus 1 divided by 2. And that is our answer. And we can compare all our answers here. For example, the first one is perfect. It fits everything perfectly, and that's also root 2. Done. So that's how you do it normally using algebra. But it's so long. You don't want to approach it like this. Do the quick method. Make sure those conditions are all met and sub them in the calculator and try each one of them. It saves you so much time. Yeah, don't make your life harder. Make it easier. Next question, question 5. If the point z is equal to 1 plus root 3i is represented on the Argand diagram, the point representing negative z, so negative conjugate of z, can be located what? So reflecting the point representing z in the real axis. Okay, there's a lot happening here. Let's first think about it. So let's draw an Argand diagram here. Let's draw a little bit Argand, like a nice Argand diagram here. Okay, so of course this is your reals of z, and this is your imaginary of z. So let's call this z. You know how we know z is 1 plus root 3i, which is basically like, let's imagine that's points 1, and root 3 scores is somewhere around here, let's say. So that point is, let's say here, that is your z. Yep, okay. Now, think what normally happens. So luckily it's so easy to do because we've got the actual formula for z, and we want this, the negative conjugate of z. So we can actually just do the calculation. So what's the conjugate of z first? Remember, the conjugate of this is you just make this a minus here. So it will be 1 minus root 3i, of course, yeah. And then you put a negative in front of it. So if you put a negative in front of it, you make sure you put a negative in front of that here, which becomes, so let me rub that out, which becomes negative 1 plus root 3i, which is basically so it'll be negative 1, so this point's negative 1 plus root 3i. So basically, just as you can see, it's just a reflection. So negative z, it's just a reflection of z in the imaginary axis, as you can see. That's basically what it is. So first one, reflecting the point representing z in the real axis, not true. rotating the point representing Z anti-clockwise about the origin 90 degrees. Absolutely not. This is not 90 degrees here. You see, this is not 90 degrees. 90 degrees, I would suppose it would be kind of, yeah, like somewhere around there. But nope, that's not 90 degrees. And you can double check that also very easily because, for example, if you have Z and you're rotating at 90 degrees anti-clockwise, you just multiply by I. Isn't that correct? So, for example, you multiply this by I, you get I plus root 3I squared, and which is basically negative root 3 plus I, which is absolutely rubbish. It doesn't even look like our answer there. So next one, reflecting the point representing Z in the imaginary axis. Absolutely correct. As you can see, that's what we said. And so what about D, rotating? So rotating the point representing Z, clockwise in the origin. Nope, absolutely rubbish. So keep it as 5C. Beautiful. Next question, 6. Let Z equal 3 plus Ki, where K is an element of all reals. The value of K that makes Z squared plus 4IZ plus 3 purely imaginary is what? A very nice question. Beautiful question. So let's think about it. So let's find this expression, of course. So let's simplify it. So Z, of course, Z is 3 plus Ki, and you're squaring it, plus 4I, and Z is, of course, 3 plus Ki. And, of course, plus 3 here. Of course, we expand it. Now, don't expand it. Let's just use our cast. Let's expand it using our cast. So, 3 plus K times I squared. I'm just going to copy this here. Plus 4I times this plus 3. There it is. So you can see that this is the real part and this is the imaginary part. Now let's think about it. If we want it to be purely imaginary, so we just want this imaginary part to exist, not real part. Of course, we want the real part to hence be 0. We want this part to be non-existent, so 0 overall. So we make it, we solve it when it's equal to 0, yeah? And so we can solve answer, comma, K. And so these are the K values, which basically make that real part 0, and hence it becomes purely imaginary. So let's write those down. We get K equals -6 and K equals 2, which is, there's no -6, so it's just 2, which is 6D. Beautiful. Next question. Question 7. A solution to this differential equation, dy dx, we got that. So we have x and y, so we'll probably have to use separation of variables. Cos x minus y minus cos x plus y can be found using what? Okay. And then all of these are just separated. Okay. So what we have to do here 100% is that here we have to, these are your compound angle formulas. We have to actually simplify them. Let's talk about that. So we know that cos x minus 2, these are all in your formula sheet. So cos x minus, just simplify this thing here first. Let's just simplify it. So cos x minus 2, what's this going to simplify to? We know cos x minus 2, just looking at your formula sheet, is just cosine x cosine y plus sine x sine y. That is basically cos x minus 2. Don't forget minus, and you got to get cos x plus 2, which is also in your thing. So it'll be cos x cosine y. Is that correct? Just let me check. Yep. Minus sine x sine y. There it is. So beautiful. And so we're going to expand it, of course. So it'll be cosine x cosine y plus sine x sine y, and then expand that negative, so negative cosine x cosine y plus sine x sine y. And you can see that the causes actually cancel out. So this is great. These causes cancel out. And guess what? The signs add up together to this. So we can just write this as 2. Beautiful. So let's rewrite that dy dx now. Dy dx is equal to e x minus y. I mean, you can put that 2 in front. It'd be better actually just putting that 2 in front. So oopsie. So 2 sine x sine y. So we've got that beautifully. Now what I'm going to do is I can of course break this down. So like for example, that it's in terms of x and y, so that's ugly. So we can, how we can do exponentials, we can just write it this here as dot e negative y, because you know when you multiply the same base, they add up, so it's the same thing. And of course, we can write this basically as a reciprocal, so like we can write it as this, e to the power y, basically, like that. Just want to make sure I haven't made any mistake. Beautiful. And so let's put this here, right there. Now we can of course simplify that, like make sure the x's are in one place and the other parts are all on the other place. So like, for example, we can write dy dx. So x is all on one, so like 2ex. So these are all the x parts, dot, and these are all the y ones. ey sine y. Done. Beautiful. So look, these are all x here, and these are all y. So because we're going to have to use separation of variables here. I'm just going to rub this whole thing part out. Let's put this over here. Now, of course, using separation of variables, I'm going to just integrate. And I'm going to reciprocate all the y's. I'm going to reciprocate them. So it'll be e, y, sine y, dy. And then integrate this here. Put that there, the x1. And that's it. That's how you would integrate that. And which one looks like that? Okay, so we got e sine y dy, 2ex sine x. It looks like C is that answer for 7. So 7C. Beautiful. Next question, question 8. Consider the differential equation dy dx xy squared, where y0 is this, equals 1. Okay, so basically where x0 is 0, and it gives us y0 equals 1. Wolf Euler's method is applied using a step size of h where h is greater than 0. Y3 is equal to that. Find the value of h. Really not bad. Let's do it. So let's use Euler method. So we know that x0 is what? It's so x0 is 0. So when you sub in 0, for example, the y value, they tell us, is 1. And how do you find x1? Of course, x1 is 0 plus h, your step size, which is just h. So your y1 is, you know, your y0, which is 1, plus your step size. And then, you know, you sub in your x0s all and y0s into this over here, just using the formula, of course. So, and that would be 0 overall, because you got to think about it like x0, y0 squared, yeah? Can you tell, just sub that in the x value. So if x0 is 0, then this whole thing becomes 0. We just get y1 equals 1, which is great. And then, so what's our x2? Our x2, of course, is, you know, your x1 step. So, and you're going to plus another step size to it. So it'll be 2h now. And so y2 is using your y1. So 1 plus your step size. And again, same thing. Now you're going to use x1, y1 squared. And we know that x1 is h. So let me write that here. And so y1 is, you're squaring, it's just 1. So, and x1 is h. So it'll be basically h squared. Done. Let's do x3. So it'll be, of course, your x2 plus h. So it'll be now 3h. And y3 is, of course, using your x2, so write that here. 1 plus h squared, plus your step size, times, again, now you're going to use x2, y2 squared. Now, we know for a fact that, what's x2? Our x2 is 2h. So first of all, let me write this nicely. So 1 plus h squared, plus h. So what's our x2? Our x2 is 2h. And our y2 is 1 plus h squared, and don't forget all squared. Done. And so this is my y3. And we know that y3 is equal to that, so I can actually equate that. 1.26528. Beautifully. And I can put this in my calculator and solve for, of course, solve for h. Beautifully. Let's do that. So 1 plus h squared. Oopsie, I want to control n that. Okay. So 1 plus h squared plus h 2h times 1 plus h squared all squared is equal to 1.12658. Yep, so 1.12658, and I can now, oh, what's happening here? What am I doing? Why is it saying multiplied? Am I not? Am I supposed to put a times here? Yeah, that's what I was supposed to do. And then I can solve this whole thing comma h, and we get two values of h, where h, if for our case, of course, h has to be positive. They told us it was positive, so h is equal to 0.2, which in this case is C. So let me write that. Oopsie, let me write that C there. So question 8 is C. Beautiful. Question 9. The length of a curve specified by x equals 1, that, and y, where t is between 0 to 2 pi is given by y. So this is a nice parametric equation, and we're trying to find the arc length. And we know the arc length formula. So we know the arc length, so is your t1, so our t1 is equals to 0, and you go into 2 pi, and we know is the square root, again, this is all in your formula sheet, so dx dt squared, plus dy dt squared dt. That's it. Nicely. And so let's do it. So let's integrate this. So first we need to find dx dt first. Dx dt is basically deriving this. Of course, you derive 1, it's 0. And deriving negative cosine. So the first deriving cosine is negative sine, and then you're putting negative, so it'll be sine, positive sine t. And of course, you're squaring it. Remember, you're squaring this whole thing, which gives you, sine squared. And the same with, dy dt. So dy dt is when you're deriving this. So of course, you derive t is 1. And when you derive, sine, it's cos, so it'll be negative cos t. And of course, you're squaring it, which means you're squaring this whole thing. Beautifully. So 0, 2 pi, square root, and now you add those up. Sine squared t plus, now I'm just thinking, should we just, let's expand that, just expand that. So it'll be 1, because 1 squared, minus 2 cosine t plus cosine squared t when you expand that. So yeah, dt. Now think about it. We have sine squared t plus cos squared t, and if you know that's equal to 1, so we can actually just rub that out and put it as 1. And 1 plus 1 is, of course, 2. Nice. Look at that. We're simplifying everything. Everything's coming out nicely. Ew, that's really large. There it is. Okay. Now, we have 2 minus 2 cos t. Now, going back to our formulas, we know that sine squared, so going to your formulas, we know that sine squared ax in your formula sheet is equal to half 1 minus cosine 2ax. So let me write that cos 2ax. Beautiful. For example, in this case, we have that causes t, basically, to really think about it, a is basically equal to, in this case, a is actually equal to a half. Yeah? And write this in terms of t, actually. Let's write these in terms of t. Write this in terms of t. So if a is, equal to a half, this will become, sine squared t over 2 is equal to half 1 minus cosine, t. Okay, we got cosine t. We're actually making good progress because if you think about it, expanding this is half minus half cosine t. Look at that. This looks very similar to that. And all we have to do is actually multiply 4 on both sides. And now if we multiply 4 on both sides, think about that. We multiply 4 on both sides. What's that? Look at that. So it will become 4 sine squared t over 2. That'll be 2 minus 2 cosine t. Aha, jackpot. That's the same as here. So we can actually replace this over here with 4 sine squared 2 over 2. And of course, that is, 4 squared is, 2, and basically cancel this out. And you're left out with this expression over here. Now, what did I just do? Sorry. So, okay, yeah. The square root of 4 is 2. Yeah, so it'll be 2 here. So it'll be 2, and the square root of sine squared is just sine t. So, and you got this, and you got this. Which looks like beautifully A is the answer for question 9. Next question. Question 10. The curve defined by this parametric equation x equals 5t, y equals 12t from 0 to k is rotated about the y-axis to form a surface so to form a surface of a revolution, the area of this surface is what? A really nice question. So you can just look at it in your what we call is your your formula sheet. Like, so it's a parametric equation, by the way. So we're going to go down to here. So surface area, and we're going to look at surface area, and where was it rotated? About the y-axis. So we're actually going to be looking at this one over here. Let's highlight that, and let's write that formula down here, and we'll use that. So T1, T2, 2 pi x, square root, dx dt squared, dy dt squared, dt. Beautiful. Let's put that back where it was, and let's use this here to our advantage. So, for example, so T1, so what's our T1? Well, we're going from 0 to k. So 2 pi, what's our x value? Our x value is 5t. And then if we get the square root, okay. So first of all, x is this. So imagine deriving it, it's just 5, and you're squaring it. It'll be 25. Plus, now, of course, the same with this. So you're deriving it, which is 12, and you're squaring it. So it'll be 12 squared, which is, of course, 144. But who cares about writing that and dt? So put this in your calculator and should simplify it. Let's do that. So 0 to k. Basically, 2 pi times 5t. Okay, just want to make sure, yep, 2 pi times that, times the square root, basically 25, and 12 squared is 144, dt, which gives you 65k squared pi. Let's write that now. So 65k squared pi. So 65k squared pi looks like 10 is A. Beautiful. Next question, question 11. The velocity time graph of a particle moving along the east and west line with velocity v at the time, t seconds, starting from a fixed origin O is shown below. The graph comprises 2 straight line segments. The initial velocity of the particle is 40 centimeters to the east. How far in meters the particle to the east of O is 150 seconds later. Okay, this is actually a typical physics question. I'm not gonna lie, I've seen this question I think it's Unit 2 of physics, actually. It's one of the most common types of question. If you do physics, this is really easy. And the way to think of it is like this. Let's just draw this particle. So let's draw this nice timeline, yeah? And let's call this the origin O. So this is the beginning, yeah? And of course, east is, to the right. This is east, so of course that's east. And of course that is west, yeah? So let's think about it. We know that this is the velocity time graph. And the area, yeah? The area represents the displacement for a velocity time graph. So let's look at break it in terms of course, positive displacement. So let's look at positive area. By the way, when it's positive area, it means it's going to the right, so east. When it's negative area, it's going to the left, which is west, yeah? That's how we know which direction it gives us. So, for example, as we can see, from the time 0 to the time sometime here, yeah? Can you see how the area under the graph is positive? Because it's above the x-axis or the t-axis. It means that it was going to the right. And how much was it going to the right in terms of distance? That's what we can find out. We can find it by finding the area under this graph. Now, to do that, it's a little bit much more work because we need to actually make an equation of this line because we don't know the x value here. And it's really easy to find the x value because, to make a straight line, because first of all, we got 2 coordinates here. And of course, we can just find the gradient of those 2 coordinates and then sub it in to make an equation of a line. So let's do that. So of course, to find the gradient, it's just y2 minus y1. So basically, it's going to be negative 20. So this y value minus 40 over 100 minus 0, which is just 100. And that gives you negative 60 over 100. Cancel those out. It'll be negative 3 over 5. And that is your gradient. So negative 3 over 5 is our gradient. So y equals negative 3 over 5. And it's actually velocity. So let me write v here. T. And don't forget the y value is 40. So you can just say plus 40 here. And that's perfect. That's your equation of a straight line, this straight line here. And we can find the x value by just, of course, letting velocity be 0. Yep. Which gives you basically 2 over 5 equals 40, which is 3t equals 200, t equals 200 over 3. Okay, so this x value over here, this one over here, let's draw it here, is 200 over 3. Let's make sure we know that. Now we can actually find the area here. So let's break it into two parts, because we got, of course, the negative area here, which means it was going to the left, and the positive area that's going to the right. So first, let's look at the positive area. So from 0 to this time over here, we need to find this area, this positive area, and that's just basically to find the area, it's just a right angle triangle, which is half base times height. So your half, what's our base? Our base is of course that 203, and our height is 40. And put this in our calculator. What do we get? So half 200, 3 times 40. There it is, and that is 4,000 over 3. 4,000 over 3, and we can make sure write that down here. So this here is 4,000 over 3. So that's the area, and can you tell it's positive? It means that basically it started at O, yeah, and it means it went, because it's a positive area, it means it was going to the right at 4,000 and divided by 3 distance. So it went, let's say, to the right. So let's say this distance over here is 4,003. It means it went that much to the right. Yeah. And then as we can see, then what happens is afterwards, this is negative area. So it means it's changed direction. So after this, so imagine it's changed direction like this. It's probably going to go to the left. And how much did it go to the left? And that's what we're going to have to check out. So we just need to find the area of this basically, which is quite easy again. Just of course half. What's our base of this triangle? We know it's 150 minus that 200 over 3. And what's our height? Our height is 20. And this is negative, of course, but so let's write that down. Half times 150 minus, of course, this here, times 40. Times 20. And this is 2,500 over 3. So 2,500 over 3. So basically, of course, it's went it's gone this much here. So it went this much distance. And this distance here, so imagine, so this distance that it traveled from here to here is 4,000 over 3. And then the distance that it traveled from here to here is 2,500 over 3. But our question is, how far is the particle to the east of O? So basically, we're trying to find here. You know how this is O? How far is the particle? Well, the particle's over here. So we want to find this distance, which is really easy. Well, we know that, this long part is 1,000 over 30, 3. We're just going to have to minus it with that, that 2,500. So 2,500 over 3. And that's going to give us that purple, which is that the distance of how far east it is from O. So it's basically 4,000 minus this, which is 500 meters to the east. So B. I hope that makes sense. So what is it? Question 11 is B. All right. Question 12. The position x meters of a particle moving in a straight line from a fixed origin O at time t seconds is given by this, where k is greater than 1. The acceleration of the particle in meters per second when x is equal to k plus 1 is y. So this is actually easy because it's x in terms of t, and we know we just have to double derive it once you get velocity, and we derive it again to get acceleration in terms of t. So let's do that. So of course we just basically double derive this. So d squared x over dt squared, and let's use our calculator to do that. So of course we go here, double derive this, which is basically e to the k minus 1 times t. Enter, and we get this. So let's write that down. Just k minus 1 squared e k minus 1 t, yeah? And then what I'm going to, of course, do is, I've got this is your acceleration, yeah? But we're saying the acceleration of the particle when x equals k plus 1, but this is in terms of t. But luckily, it's not too bad, because you know how this equation here, it was in terms of x, isn't it, yeah? It's in terms of x. So what I can actually do is, I know that x is k plus 1, and I want to find the t value, the time that it took, because we know that x is, equal to k plus 1. I can easily find t by solving it. So I'll solve answer, comma, t, and this is the time it takes, basically, in terms of k. And I can, you know how acceleration formula is this? I can actually sub that in there over here to find the acceleration at x equals k plus 1, which is, this is your acceleration. So let's write that down. So acceleration is basically k minus 1 squared k plus 1, which looks like, of course, it doesn't look like any of them because this here is the difference of perfect squares. So you can write it as k minus 1, two of them, k plus 1, and of course we can just put one of them together because it's just differences of perfect squares. And that's going to be k squared minus 1, which looks like it's C, so 12C. Next question is 13. If the angle between the vector this and this is this, then the value of m, where m is an element of all real parts, is what? What a beautiful question. It's so easy. We just have to use, of course, we know that the angle, to get the angle between two vectors, is a dot b is equal to the magnitude of a times the magnitude of b times cosine theta, where theta is your angle between those two vectors. And we can just actually do this all in our cast. Let's do it, and let's define those two vectors. Let's define vector a as, of course, 2, -1, 2. And let's define b as the vector, the other vector, which is 2m6. Yep. And so put them in that formula. So we know the formula is, of course, the dot product, which you can get vector dot product of a and b. So the product of a and b is equal to get the magnitude, you have to write norm of a, and of course times the norm of b times cosine theta. And our theta angle, they told us, is the cos inverse of 13 over 21. And enter, and we get this. And we can just solve answer, comma, m. And we get these two values. Now we know m is all real plus, so it's a positive number. Of course, it has to be m equals 3. So we can choose, for 13b. Okay, so question 14. Consider the vector r and s, where the magnitude of r is equal to 9 and s is this vector. If the vector resolute of r in the direction of s is equal to this, then the scalar resolute of s in the direction of r is equal to r. Okay, so basically let's write the formulas and see what we can do with that. So we know that the vector resolute, so r dot s, so look over, so in the direction of s, of course, so s will be squared dot s, the vector s, and that's going to be equal to this here, this vector, -4i plus 4j minus 2k. And so we know that the vector resolute, of course, it's the scalar resolute of s in the direction of v. It doesn't matter. So when you do the scalar, you can do r dot s or s dot i. It doesn't matter. So we can just write it again, r dot s. But in what direction is it? It's in the direction of r. And we know the magnitude of r is just 9. So we can actually just replace that with 9. And this is what we want to find out, this whole expression. So we just need to find r dot s, the dot product. And that's not too hard yet, because coming back here, let's take this here. Oopsie. Let's take this here. Okay. You know s, yeah? We know what s is, the vector s, yeah? We know that vector s is 2i minus 2j plus k, and this is what actually gives the direction of the vector. Remember, this here is just a number. It's just it's not a vector, it's just a number. It could be negative, positive, but it's just a number, and it's being multiplied by this vector over here to result in this vector. And I think you can see the pattern here. We know for a fact that this over here has to be -2. Think about it. Negative, if this is negative, this whole expression is -2. Does that make sense? Because, like, for example, it has to be -2 because, if this was -2, yeah, this whole expression, and then you times it by this vector over here, 2i minus 2j plus k. Do you see how it will result in that -4? Look, -4i plus 4j minus 2k. Do you see how it results in this here expression? So it is actually equal to -2. So what we can do is kind of, we know this whole expression here is equal to, this expression here is actually equal to -2. And we know that, like, s is that, so if we find the magnitude of it, the magnitude of s is what? It's just 4 plus 1, which is, basically 3, and you square both sides, it'll be 9. Sorry. Alright, so that'll be 9, and so times both sides, it'll be -18. That's it. So it'll be negative 18. So R dot S, the dot product is negative 18. So we can put negative 18 here. And that'll be negative 2. That is your scalar product, basically. Yeah, basically your scalar, the scalar resolute in the direction of R. Yeah, negative 2. So choose B. Really not a bad question, but yeah, you can easily make some mistakes with this one. So just be careful. Let's look at the next question. Question 18. The position of a moving body is given by this. So R of t is equal to that. Okay, where t is measured in seconds, where t is greater or equal to 0. The motion of a body can be described. So the motion of the body can be described as moving along a, basically, let's not checking this. Moving along a parabolic given path given by these. Okay, so we've got the equation we need to find, and it says starting at 0, 1, reversing direction at 1, negative 1, and then again negative 1, negative 1, then return. Okay, first, the most easiest is just to find the equation. It's really easy to find the equation of parametric. We know this is the x component, so the x component will be x equals what? Sine t. And the y component is going to be cosine 2t. Now, we know that cos 2t is what? Well, let's simplify. We can just look at it in our formula sheet, of course. So going down, cos, basically it's cos 2t. You can write it like this, but we have sine, so we can actually write it as this. So this here, we can replace it as 1 minus 2 sine squared t. Okay. And y equals 1 minus 2. We know that sine t is x, so 1 minus 2x squared. That is your equation. Which is not B, and it's not D. Now, let's see what's the difference between A and C. So A says 1, so it's the same equation. So it starts at 0, 1, which both do that, and they reverse the direction at 1, negative 1, and then again at negative 1, they do that, and then they return to 0, 1 after pi seconds. The other one's 2 pi. Okay, damn, so the difference, the times are different here. How do I know? Well, let's just, what I'm going to do is do this, actually. I will, actually, yeah, I will basically do this in my calculator. Let's do this in my calculator. I'm going to define it, yeah? I'm going to define it and actually understand what is happening, because it's really hard to understand. So R of t, I'm going to just define it. So it's sine t cos 2t. And I'm going to, I can actually also graph it. So parametrically. Parametric. So of course we have sine t, cos 2t, and there it is. So we get, okay, we can see it's just a parabola. Look with this 1, that's negative 1. So that's, yeah, that's negative 1, negative 1. Yeah, that's perfect. Like it makes all sense. And that's negative 1, negative 1. That's 1, negative 1. Okay, perfect. So that's a parabola. So let's think what's happening. Let's actually graph this in our thing here. In our iPad, so let's just graph and see. So we have this over here, and we've got this parabola that looks like this. With this here is 1, and this here is negative 1, and this point here is negative 1, and that here is 1. Let's think of what's happening. So let's go back to our cast, and let's see. Does it start at 0, 1? So what I'm going to do is just go on my cast and write R of 0. So when t equals 0, when does it start initially? Yes, it starts at 0, 1. So imagine going back here. Imagine it starts at 0, 1 here, yeah? Now let's say in 1 second later, 1 second later, what happens? So R of 1. Then it becomes, 0 0.84. Well, I'm not sure. Okay, we got that. Now, actually, that's a little bit hard to even understand what's happening here. So let's come back to our iPad. So the difference is the time, the total time that the path. So let's look at A first. Let's just generally think about it. Let's look at A. So it says it starts at 0, 1, yeah? So imagine you start here, of course. Yep, you start over here at 0, 1, yeah? And it says it reverses direction at 1, negative 1. So basically, so imagine this, yeah? So it goes through this. It goes through this whole path, yeah? Reaches 1, negative 1, and then it reverses at 1, negative 1. So it comes back. So imagine it's coming back, yeah? It comes back to where it was. And then again at negative 1, negative 1. So again, it goes back to negative 1 to 1 here. And then returns to 0, 1. So again, it comes back to negative 1 to 1. Okay. And it after 2 pi seconds. So basically this whole part, like this whole, the distance it walked was, it took 2 pi seconds. And it's the same with C. It's all the same stuff, but the other one took pi seconds. Now, let's think about it really understandably. Now we know by symmetry, yeah? That the time it takes, yeah? Because you know how this whole time here, yeah? So imagine like this. So we know it went this way once, then it would come back, so that's 2. And then it went once. Oh, oops. So what happened there? What just happened? Oh. Okay, something like this. It went once here, yeah, and then it came back. So that's like 2 paths, yeah, like 2 times. And then it came here once, and it came 2 times. So that's 4 times, yeah. And this is all symmetrical, yeah. So what I'm gonna do is this. So if it take 2 pi, yeah, the whole time, like the whole overall, to the path, all of it, and we've went 4 times, yeah, like this whole distance, yeah. How long it took? It took some time, and then we came back. It took double that. So imagine, okay, so the time it takes, so think about it like this is what I mean. The time it takes to go to here, let's call it 1 second, yeah? And then they come back, now that's 2 seconds, yeah? And they come back here, that's another 1 second, so that's 3 seconds, yeah? They come back here, and that's 4 seconds. So basically, we're going to divide 2 pi divided by 4 to actually find, which is basically pi over 2. So basically, it should take pi over 2 units, just pi over seconds, like pi over 2 seconds to come here to here. And we can double check that. Let's double check that. If I sub in t equals pi over 2, it should result in this coordinate 1, -1. Because it would have been gone from here all the way to get. Let's check that. R of pi over 2. Aha, 1, -1. That looks correct. Now, if we did that with the same thing for the other one, which is pi, so imagine like pi divided by 4, yeah, which is pi over 4. No, you get root 2 over 2. So basically, coming back to our cats, it's actually A. Because the other one, so let's come here. The other one is basically, we're basically saying pi over 4, of course. So that's the time it takes. And when we sub that in, we actually only go from here all the way to here. Not actually this whole path. So that's absolute rubbish. So it's A. That's really hard because there's a lot of critical thinking in this one, actually. So yeah, that's how you do that one. 16. Particle 1 has a position vector of this, and particle 2 has a position vector of this, where t is measured in seconds from 0 to pi over 2. The number of times the velocity of particle 1 is perpendicular to the position of vector r2 during the first, pi over 2 seconds is what? Actually, a really nice question, because if we can just define r of 1, so like r1 of t, to like r1, that we want the velocity of particle 1. So the velocity, of course, is deriving it. So let's put a dot here. So this is the there. And we want it, if it's perpendicular, so the dot product, of course, the dot product to the position of r of t. So r of 2, so that's the position. So look, we dot product them, and if they are perpendicular, the dot product must equal to 0. And we can actually solve this here. And of course, we want to solve for t between 0 to pi over 2. Let's just do this with our CAS. So I'm going to control N, and I'm going to actually define these in my CAS. So r1 of t. This one doesn't seem too bad. I've seen this in the past papers, so really good repeated question here. Cos t here, sine t, sine 2t. Okay, so what I'm going to do is, I'm going to derive r1 of t. So that's, and I'm going to, of course, that's that. So first I need to find the dot product, we said. Dot product, so of this, dot r2 of t. And I have not defined r2 of t, damn! R2 of t. Which basically, I'm just going to kind of copy this. Which is basically now, this is sine. The other one's cos. And the other one is sine 2t. So the same thing, basically. And so, what I'm finding is the dot product. Vector dot product of this, dom r2 of t position. And so we get this, and of course we want this to be equal to 0. And we can solve answer, comma t. Of course, t is between 0 to 0 less or equal to f, t to pi over 2. And so there's only one time. So actually, the number of times it's only once, it looks like. So let's choose 16A for that one. Next question. Consider the following parallel lines. So we have L1 and L2. And we can easily see that they are parallel because we've got these here are the same here. These, directional vectors, basically. The shortest distance between L1 and L2 is what? Okay, not a too bad question. So really quite easy, because if you just draw. So if we draw one vector over here, let's call this line. Let's call this line 1. Let's call this here line 2, yeah? So that's L1 and L2, and they are parallel. Can you see how they're parallel? Well, the shortest distance is this distance over here, some distance over here, yeah? It's going to be the shortest, and of course, these are perpendicular. Now, for example, you just need to pick a point. Let's call L1, yeah? Let's just pick a point. Let's call this point here. Well, it's easy. We know our coordinate that we can have is this coordinate over here, which is basically, it really is just 1, 3, and 1. This here, this vector. Yep. But for L2, we don't know where it is. Like, in terms of time, we don't know. It could be, yeah, we don't know where that actually is. So what we need to do here is we need to write it in normal vector. So let's call this A. Let's call this B, this point here. And we're going to write it as normal, like, you know, R of 2 of t. So in terms of time. And we need to find that time where these two lines are actually perfectly perpendicular. So this one over here is going to be -2. Expand this to -2 plus t. So look, can you see -2 plus t? So just expand that. That's your I component. That's your j component. And that's your, so 3 plus t. Your k component, yeah? And of course, let's find, you know, the vector AB. We know that the vector AB, so if we find the vector AB, which is, of course, -OA plus OB, yeah? So that we can easily find that. We know, and we might as well find it now, actually. So negative, what's our OA? OA is basically, oh my, oh, okay, so I might as well not even use vectors here. I just cannot be bothered with vectors. But yeah, let's just use vectors. So, you know, that's going to be I plus 3j. Should have used vectors, yeah, plus k plus OB, which OB is just basically -2 plus ti. 1 plus tj and 3 plus t. Okay, now just expanding that. Okay, and so, okay, well, we know that the I components just all add up anyway, so just make sure we write that nicely. Okay. Damn, why am I making my life so hard, man? Generally, yeah, so that'll be like -3 plus ti, that's the I. And so if you add up the j, it's -2 plus 2j plus the k is basically like 3 minus 1, so plus 2 plus tk. Damn, I was just not worth it. We should have made it much more easier for myself. Don't know why I took that long for this one. So that's my AB, yeah? That's my vector AB. And I'm hoping that my algebra is not wrong. And if it is wrong, just could have done it with a calculator, to be honest. And I just did all this extra work for nothing. But it should be something like this, yeah? So this is my vector AB. And we know that AB has to be perpendicular to both line 1 and line 2. And it doesn't matter which one you choose, but just one of them, because they both have the same directional vector. So what we can do is we just need to multiply like AB here, dot product that, with like this here, the directional vector, which is R plus J plus K. And of course, it has to equal it to 0. I'm really taking the long process here, which is not really good. So, for example, like -3 plus t. So let me put that, comma, -2 plus t. And 2 plus t. So that's that one. And so I'm going to find the dot product of this comma with basically 1, 1, 1. And I want this to be equal to 0. Solve answer, comma t. So t equals 1. So, okay, we've got so much work. Okay, so we've got the value of t. So t equals 1. I mean, so you can actually sub in t equals 1 to all this. Like, what's -2 plus 1, which is -1. So b is going to be -1. That'll be 2 here. And that'll be 4 here. So we can kind of replace this here. This coordinate will be nicely now. -1, 2, 4. So this is where this perfectly occurs when they are perpendicular. And we can find the distance of AB by just using a formula. Like, you know, AB, minusing these two vectors and finding the magnitude. So, like, for example, let's find, for example, just you can minus like BA. Let's find, let's just minus EA. What you can just do is just minus these two and then take the magnitude. That's just the smartest way. So what's negative 1 minus 1? It'll be negative 2. So I'm going to say negative 2i. What's 2 minus 3? That'll be negative j. And what's 4 minus 3? So plus 3. Okay. Let's take the square root of that. So it'll be 4 plus 1 plus 9, which is root 14, which is b. Yeah, not really. That was dumb of me to do such a long process. There's an actual formula for this. I don't know why I did this, but that's how you would even think of it critically. But yeah, that took too long. 17, yeah, 17 is B. Question 18. The point of intersection of the line this. So this is the line where T is an element or reals, and the plane this is what. This is actually really, I love point of intersection because it's so easy. So of course, write this in terms of like your actual I and K, J and components together. So like we can write this as R of T. So the I component's 1 minus 2 Ti plus 1 plus 2J plus negative 2 plus 3tk. Yeah. And so this is, of course, your x component, 1 minus 2t. Your y component is 1 plus t. And your z component is equal to negative 2 plus 3t. And I can sub that into this over here. So 3, my x component is 1 minus 2t. Minus 2, y is 1 plus t. Plus 4, z is negative 2 plus 3t equals 5. And I can use my calculator to solve this, which I can easily expand. So 3 minus 6t minus 2 minus 2t minus 8 plus 12t equals 5. Hoping that I don't make silly mistakes here. Damn. That's negative 18, that and that. Then, of course, do plus 12t in that, so it'll be 4t with that. 3 minus 2 is 1. 1 minus 8 is negative 7. I'm not mistaken, yeah? And it's equal to 5. 4t equals 7 plus 5, which is 12. So t equals 3. Okay, we got the t equals 3, and now we can actually just sub that into all the x and y and z. So t equals 3 is where the point of intersection occurs. So example here, so x will be, so if I sub in 3, so 1 minus 2, 3. It'll be negative 5. Which one has negative 5? It's not that one. And so what about the y value? So of course, if I sub in, 3, it'll be 4. Which it looks like D is the only answer there. So 18D. Not bad. Love that question. 19. When conducting a hypothesis test, a type 2 error occurs when? So let's think about type 2 errors. One of the best ways that I even memorize my type 1 type 2 is I've actually look at the Jacaranda book and I've memorized this table, and it's so easy to memorize. So let's talk about it. It's basically doing this. So you just have to memorize, like, okay, here you write H. So your null hypothesis is true. Write that, true. And of course, here you write the null hypothesis is false. Look, that. So just draw that. Nicely like that. Yep, look, this table. And you do the same here. So for example, here you just a little bit move it out. So of course here, then these ones here, you have to say you accept your null hypothesis or you reject null hypothesis. And that's it, look. So it's all about null hypothesis here. And there it is. Look how easy. Okay, and so what we do is this. Okay, for example, if your null hypothesis is true, of course we should accept that. This is a tick. This is the correct method. And of course, when your null hypothesis is false, we want to reject that. This is also proper. This is the correct method. But then these are where the errors occur. So this first error, the error that occurs here, I know for a fact, remember, so oops, is a type 1 error. Type 1. And here is a type 2 error. So, for example, we're looking at type 2 errors where basically what happens is where your null hypothesis is false, but we unfortunately accept it. That's what we call a type 2 error. For example, okay, let's look at A. It says a null hypothesis is not rejected. So we accept the null hypothesis. Yep, we accept the null hypothesis when the alternative hypothesis is true. And that's true. That's your type 2 error because look, when your null hypothesis is false, it means you've accepted the alternative hypothesis is true. Does that make sense? So A, that was really easy. A, just using that table, yeah? Look, so a null hypothesis is not rejected, so we've accepted your null hypothesis, yeah? Look, not rejected, so we've accepted it when the alternative hypothesis is true. Look, because your null hypothesis is false, then of course the other alternative has to be true. So this is called a type 2 error. That was really easy, just doing that table there. 20. The masses of avocados in a crop may be assumed to be normally distributed with a mean of 200 grams and a standard deviation of 7.5. So it's called that masses of avocados. Masses is normally distributed with a mean of 200 and a standard deviation of 7.5 squared. Okay, after an avocado of mass M is peeled, so you peel it and the stone is removed, the mass of the edible fresh F, which is now called grams, is given by this. 4 avocados are randomly selected from the crop. What is the probability, correct to 4 decimal places, that the total of those of more than 570 grams of edible flesh is obtained? Okay, so basically, think about it like this. So we want the total of edible fresh, and we have 4 of them, yeah? We took 4 of them, so basically F plus F plus F, we want those ones, yeah? And we know F is, of course, we can write it as, F is just 0.7 m. So 0.7 m plus, and there's all, 4 of them. Of course, we need to find the, we need to find the expected value and the standard deviation. So, of course, the expected value of t is just finding the expected value, of course, 0.7, and all of the other ones. And, if you find the expected value of like 0.7 m, the 0.7 just comes out, and it just be, and imagine doing that for all of them. Like expected value, it'll be that. It's basically 4 of them, basically. You'll just have 4 of them, actually. Like, you'll have 4 of that 0.7, basically. Okay, beautiful. So that's what your expected value is. And so we know that the expected value of M anyway is 200. And that will give you what expected value? Let's do that in our CAS. 4 times 0.7 times 200. And that's 560. 560 grams. Now let's look at the variance of T. So the variance of T, of course, is like finding the variance of one of them, like 0.7 m. So 0.7 m. And of course, when you have a constant, you have to take it out. You have to like take the square of it, take it out. So like be this 0.7 squared. Now imagine like you do that but 4 of them. Yeah, of course you're gonna have a 4 in front of it. You can just shorten it by putting a 4 in front of it here. And so that is basically, yeah, your var of T. And of course, var of M is what? It's just basically 7.5 squared. And we can just find easily the standard deviation of T by just taking the square root of this variance over here. So for 0.7 squared, 7.5 squared. Not plus, sorry, it's a times. Because we can simplify just using our CAS. Okay. I feel really tired, so I'm just trying to get this period 7.5 squared. And that's 10.5. 0.5 grams. And so this is your standard deviation. And basically what we're trying to find is the probability that the total, so T, is more than 570. That is piss easy. Let's do that in our CAS. Go, of course, menu, our probability distributions, and we're going to go to normal CDF, where we're going from 570, of course, to infinity. The mean is 560, and the standard deviation is 10.5. And you press then, enter. That is your probability, which is B as your answer. So 20B. And that's it. I hope this video helps you with your studies. I mean, this paper's all right, but there were some tricky questions, I'm not going to lie, but not too bad of a paper. I hope you guys enjoyed this video and take care of yourselves. Bye-bye.